Hello, Algebra 1B. We're talking about solving quadratic equations with the square root property. This is section 10.4 out of your Algebra 1 textbook. Um, what the property says is this. If you have x squared equals a number that's positive, it's going to have two solutions, x equals positive and negative d. One way to think about this is that if you do have, let's say we had x squared equals 9. There are two solutions to this equation. One being x equals 3. 3 squared is 9. The other being negative 3 because negative 3 squared is 9. And what we're doing here is introducing another way to solve an equation. We're undoing a square. And to undo a square, we're going to square root both sides. Um, in this case, we're going to notice that the square and the square root go away, leaving x by itself. And then this will leave us with two answers, x equals positive and negative 3. What you want to do is recognize when to use this property. As we go through these examples, let's look at some similar characteristics. Here's two equations. Here's another one. And as we look at these examples, one thing you may notice is that every single equation only has one variable. Another thing you'll notice is that you have a square. All right, so that's two characteristics that we're going to be exploiting with these equations, and these have to exist for this property to come true. Um, so as we look at these two examples, what we're going to have to do here is isolate the x squared, and I'm going to do that here by dividing by the 2. The 2's cancel out and leave me with the x squared equals 4. And so what we now have is our new tool we can use to isolate the x. If I square root both sides, I will undo the square, and that will leave me with an x by itself, and I'll have the square root of 4, which is 2, not forgetting that we have the positive and negative 2. Over on this example, m squared minus 18 is negative 18. Let's see, we have to isolate the m squared, so we'll add an 18 to both sides. Doing that step will reveal m squared is equal to 0. And then using the square root of both sides, I won't show it this time, but the idea is we square root both sides. We get m equals the square root of 0, which is 0. All right. As we look at more complicated examples, here's one. We're going to divide by the 4 to isolate the z squared. Once the 4 is canceled, I'll be left with z squared equals 9/4. And then once again, the square root property says that if z squared equals 9/4, then z is going to be equal to the positive negative square root of 9/4. Now, when I square root a fraction, what I'm going to do here is just square root the top and bottom. Both of these are perfect squares. So I'll have the square root of 9 is 3. The square root of 4 is 2. So z in this case is going to be positive negative 3/2. Looking at this example, you can see it's a little bit different. One way to think about this is think about the operations that were done to produce the left-hand side of this equation. They started with an x, and then they subtracted a 4 from x. Let's see, and then after that they squared everything. So they took everything to the second power, and then after they squared, they took everything times 6. If you can recognize that these were the steps to sort of say wrap x into what it looks like now, to undo this, we're going to go backwards, and we're going to undo these with inverse operations. We're first going to divide by 6, on both sides. Let's see, that's going to leave me with x minus 4 to the second power equals 7. And going along my list I've made, we just undid the multiplication by 6 by dividing by 6. To undo the squaring, I am going to square root. That leaves me with the x minus 4. We don't need those parentheses right now. So let's see. I'm going to rewrite this as x minus 4 equals positive negative radical 7. And then once again, looking at this list of operations that was done to wrap x into its equation, I am going to undo this now by adding a 4. And so once I add a 4 to both sides, I will get x by itself, and your answer will look like this. You'll have plus or minus radical 7 plus the 4. Now, sometimes we can reduce that radical when I take the square root of, let's say it was 16, but since 7 is a prime number, it does not simplify, and this would be the answer I'm looking for. Here's another good example. Thinking about how m was enclosed or wrapped up in its expression, the first thing, I think they took m to the second power, and then they multiplied by 9, and then they added the 8. Now to undo these, I'm going to go in the opposite direction, and I'm going to do the inverse operation. So we're going to subtract 8. 53 minus 8 is 46. Sorry, 45. So 45 is the same as 9m squared. And looking at my list of operators here, I'm going to go, let's see, to undo the times 9, I have to divide by 9. Let's see, that's going to leave me with 5 equals m squared. And to undo the m to the second power, I will now square root both sides, not forgetting the plus or minus radical 5 equals m. And I would stop with that. Let's see, one more example here. So as we kind of see, we have to get rid of they subtracted 8, and then they squared everything. So I'm going to write this over here. From C they subtracted 8, and then they took that whole thing to the second power, and then they took it times 1/2. To undo these operators, I've got to go the opposite direction. I've got to multiply by 2, take the square root, and then add the 8. So let's see, multiplying both sides by 2, that undoes the 1/2. That leaves me with c minus 8 to the second power equals 6. Let's see, I have to undo squaring, so I'm going to square root both sides. That leaves me with c minus 8 equals positive negative radical 6. And then adding 8 to both sides to isolate the c will give me the final answer. C will equal, we write that as positive negative radical 6 plus 8. Now, as we look back through these examples, you're going to recognize a couple things. First is that when I did the square root, I always had a positive number, and I always had a number that didn't reduce. So let's talk about those two cases. In this case, I did have a number that reduced to 3 halves. So that was nice. Oh, the 4 reduced to 2. Um, but over here at the beginning, when we talk about if D is positive, then it has 2 solutions. So what happens when D is negative? So I'll just write an example here to talk about that. I could have x squared, let's go plus 4 equals negative 2. Let's see, this is an easy x squared to isolate. I will subtract the 4. This leaves me with the x squared equals negative 6. Square rooting both sides, I'll get x equals positive negative radical negative 6. And here we want to recognize that if you square root a negative, there is no solution. And it goes down to a square root of a number. Let's say the square root of 9. The square root of 9 is equal to 3. That is because 3 squared is equal to 9. So if you're going to square root some negative number, that means that when I have to find a number that when I square it equals a negative. So the question is, what number squared equals negative 6? Well, I can't ever square a positive or negative number and get a negative number. So whenever you're square rooting a negative, we're looking at a no solution case.